Hi everybody, and welcome to this panel discussion on safety within industrial refrigeration. My name is Anders Olsen, and with me today I have a strong lineup consisting of Niels Vestergaard, global application expert with more than 39 years of experience. Also with me today I have Thomas Lund, also global application expert. Thomas has more than 20 years of experience working within industrial refrigeration. And last but not least, we have Alejandro Lopez with us, and Alejandro is responsible for the portfolio development of our safety devices, among a lot of other things. But today we have a very ambitious plan and a lot of things we have to cover in this discussion, so I think we have to get right at it. And I believe it's fair to say that safety is one of the most, if not the most important aspect when designing and building industrial refrigeration plants or systems. But safety can take many forms, and today we have decided to focus mostly on the safety for the people working close to these plants. So and let's just get started. And I think the first thing to start with is the refrigerant. And I think it's safe to say that ammonia is considered the most efficient refrigerant we have for industrial refrigeration systems. But there are also some safety considerations coming into play using ammonia. Can you elaborate a little bit on that?
Yes, definitely. I mean, ammonia is toxic, and granted a very narrow concentration band, it is also flammable. So it is of course a substance that you need to be very careful about. In the same way, we also have often very large charges when we have the industrial systems. So of course the potential danger is rather big when you have a big charge. We see in many regions that the government or the authorities are putting on legislations to control the size of the charges and control the ammonia systems, and that incurs a lot of cost and a lot of work for the ammonia operators. So we do see a lot of different moves towards lower charges, towards other refrigerants. And with regards to the last, I would like to say that it's not just ammonia that's dangerous. It's every substance on this planet that is dangerous. The shift is going towards CO2 for one, and I know that in slaughterhouses they are killing pigs with CO2, so it is also not completely safe. But we have a majority of our systems with ammonia in industrial refrigeration. So of course that is the primary focus of our talk today.
And picking up on one of the messages from Thomas, which is very relevant, is as he mentioned, other substances are as well, toxic or dangerous in some way. And of course, ammonia is, a little bit special because we are talking at very low concentrations that it can be harmful in different ways. But one thing that we have to highlight, on this is that it has one property that makes it self-alarming. And that is, the very strong odor that it has. So that is definitely one thing that we have to consider when we compare to other substances, which might not be toxic at low concentrations, but as well, they don't have any odor. And then it's, quite difficult to, to detect those, dangerous concentrations by just, smell. So definitely a very important thing as well to consider on this end also, this property from ammonia that is helpful to make it,
yes,
self-alarming.
Absolutely, and it's my personal opinion that we have seen accidents with ammonia. We have seen people die from ammonia, but you have to consider that most of the ammonia systems, or let me put it the other way, most of the industrial systems are with ammonia, with the vast majority. and it's very, very big plants in a very concentrated state. So we have a factory with many tons of ammonia. And if you compare that to what we have seen the majority of, for instance, in CO2, it would be a relatively modest charge in a rather big supermarket, square meter wise. So we have a very big concentration of refrigerant in an industrial system, and that makes it by itself relatively dangerous. And it's my belief that this is the reason why we see people die from ammonia. I think that if we replaced every ammonia system with CO2 systems, people would start dying from CO2.
Well, thank you. You mentioned shortly, Thomas, that lowering the charge could be one way to mitigate the risk. How could that be done? Any of you?
Yeah, I think there's a lot of ways to do that. Over the years, the ammonia system has been built. We can say in the easiest way, and without focusing on the charts. So there are systems, as Thomas mentioned, with a huge amount of refrigerant charts. But during the recent years, there has been a lot of focus on we can say the safety. And one of the ways to improve the safety is to reduce the charge of ammonia. What you can say, what can be done is that you can, for instance, make a cascade system with ammonia and CO2, where you have the CO2 on the low temperature side. And by that, you can lower the charge to approximately 1/10. That's one possibility. That's a solution that has been used for a number of years. But you can also look into, we can say, more traditional ways to build a refrigerant system. And some of the activities which are going on is to, instead of use the refrigerant in a pump circulating system, then go into a direct expansion system. And by doing that, you can lower the charge to approximately the half of what you have in a pump system. Or you can go into a solution where you, instead of having one big installation, you could design your system with a number of, for instance, rooftop systems. And by that, you can lower the charge quite significantly. But the most important that in that, if we're going in that direction, is that if there is an accident, then the accident will only be in a small part of the system, so that the total ammonia charge that could escape is much less. So that's some of the ways you can go, but can also, of course, go by a chiller where you combine ammonia with a brine loop. But all these ways,
but sorry.
Yeah, but all these ways, you can say there are some pros and cons, which has to be evaluated, and that is really what is very important and what is also going on. Yeah, Thomas.
I think that exactly what you said, the pros and the cons. I think safety is, of course, always an issue and something that we strive to improve. But the last many years, we have also been looking into the efficiency of the systems. So the object here is to reduce the charge and increase the safety without sacrificing the efficiency on that also, because then we have another front that we are fighting these years that we will shoot ourselves in the foot with. But fortunately that there are solutions where you can reduce the charge and still keep your efficiency high. Niels mentioned chillers, for instance. When you do that, you replace the refrigerant in in the evaporators with glycol that you cool in a chiller unit, but that increased temperature difference that you have in the chiller unit that reduces your efficiency. So that is not the most fantastic way to go. It's a simple and it's a easy way to go, but it's also one of the places where you lose efficiency. But we have a lot of other suggestions to how to do it. One of the better ones, I think, is the distributed rooftop systems, where you can reduce the length of suction and wet return pipes and so on, where you could have a lot of refrigerant lying in. And again, if you have a leak, then it's only part of the system that leaks. Yeah.
Yeah, very interesting. This reduction of charge, can that only be done on when you build new systems, or can you on existing system also achieve this or lower your charge?
Well, it is very difficult to lower the charge in an existing system, because all the pipe work has been dimensioned to a certain type of system. And if you are going and try to reduce the charge, you would still have, we can say, often very large pipes, and then you will not have the right flow velocities. So generally, I would say that is really difficult to do that in an effective way. But with new system, there are a number of possibilities.
Okay, thank you. Going forward, we have now looked at the refrigerant, and we have looked at what kind of system you could use. If we dig a little bit deeper into the system and look at other aspects where you have to consider safety, one of them is how you defrost. Can you tell us a little bit more about the safety considerations here?
Yes, it is correct that you can say defrost in a refrigerant system is a very important thing to do, and there are many ways to do that. But if you want to make an effective defrost, and you're also looking into to the cost, then you turn out that the hot gas defrost is a very good option to do so. Because in a hot gas defrost, you can say you use the internal energy to remove the ice from your evaporator. You simply take the energy that you would bring to the condenser and use that to defrost. However, when you are doing that, you are taking some hot gas and inject that into a cold evaporator, and there you really need to do that in a very in the correct way and in the safe way, and that is one of the areas where you really need to know what you are doing, because if you just if you do not, we can say, follow the rules, there is a risk that you can create a dangerous situation, and in worst case you can destroy your system and create a large leak in the systems. That has unfortunately been seen as some cases worldwide.
You can create life-threatening situations with this.
Yes, definitely.
Yes.
So therefore, it is really important to know how this hot gas defrost has to be executed, and how it has to, the timing should be when you empty your evaporator and how you inject your hot gas. And that is one of the areas that we have spent quite a lot of resources to come up with some safe and efficient solutions. And what we have done recently, we have released an evaporator controller, EKA 400, where we have been looking into these sequences, how to perform that. So everything which is important that has been taken into consideration in this controller.
And I will add that, here we have touched on a very important topic. Unfortunately, as mentioned by Thomas and Niels, some of the most, I would say, infamous accidents related to, ammonia are found, the cost to be, related to the process of, of hot gas defrost. So there has been definitely a trend to put more attention into this, which is needed. And in addition, to components that are very relevant for this, like the, like the evaporator control that has a standardized sequence, that helps you guarantee the safety. There are also other components that we have been working, on, such as, the two-step or the soft, gas injection for the, for this process, where Danfoss has, recently released a dedicated product for this that will help us prevent, some of the risk that are created during this, during this process. Definitely, a very important part of, of the processes, where it's not just about components, but it's also as well about training, the operators, and having them aware of the risk that you are running with running this this process. Because as Thomas mentioned, the situation that can be created here is, life-threatening, not just for the people that is, on the facility, but when the charge is very large, the risk can go, even higher outside of our facility if something goes wrong on this part.
Yes, definitely true. And besides the EKE 400, which has just been released for other applications such as DX and CO2, we also have other tools which can help our customers designing safe systems and construct the defrost in a safe way. Can you mention a few?
The one that springs to mind, of course, is our Cool Selector 2. I think that most people know the Cool Selector program and know that it is a fantastic tool. Alejandro mentioned that the training for the operators and so on of the equipment is very important. But I would say it's also very important to get the correct way to build up, for instance, a valve station and dimension all the valves correctly. And in that sense, the Cool Selector is fantastic. We have what you call it, wizards almost, that where you step by step run through a couple of questions, and then it designs the valve station for you that has all of the features that you need to have a good and efficient operation, but also a safe operation. And I believe that the EKE 400 setup will also be merged into Cool Selector here in the coming months or weeks. So it's very much focused on doing everything the best possible way.
But we also think that you should mention that we also have a very comprehensive application guide that can support the designer in how to design the system for a different part of the systems. I think that is also very important here.
Yes, it is. It is, and should detail why and how we should do things in the best possible way for safety and efficiency and practicality. So yes, that's a very important tool as well.
Yeah, and just mentioning that the application guide is free for download on our website, so so it's available for you there. Talking about designing system, one aspect of the system which we also have to look at is draining oil from an ammonia system is also a potential risk area, right?
Yes, definitely it is. We can say this is something that you can say has been known for many years, that this has to be done in a safe way. The problem is that you are collecting oil in your system at the low temperature part of your system, and you need to get rid of the oil. The oil draining is, we can say, can be time consuming, and there is a tendency that we can say people do not really take fully care of the risk when they are doing so. And if then it goes wrong, then it can go really wrong, and you can discharge a lot of refrigerant into the atmosphere. Unfortunately,
after all, you are opening up into the insides of the refrigeration system. So
yeah.
So I don't know why it should not be something that people take seriously.
No, but there are some methods, you can say, where you can by design you can minimize the risk. So first of all, if you design your system in a way so you do not drain the oil directly from the big vessel where you have the big amount of refrigerant inside. In that case, you can say if things go wrong, then the amount of refrigerant that you have will be much less. But still, if you are following the procedure, having the right equipment, put the right valves on your system, that can be done very safely. And we absolutely recommend people to design the system in the right way, but also follow the instructions. But here you can say we have instructions, but we also have very nice instructions from IIR how to describe all these things in detail. So the knowledge to do it in a safe way is absolutely there.
Yeah, and I guess one thing to highlight is, what Thomas mentioned. At the end of the day, we are opening, the system to, to environment. So there is very detailed, requirements, as Neil mentioned, from our standards, and big part of that is, related to the way, in regards to the design, but the critical part here is, the operator and the procedure that they are following. At the end of the day, on this, on this process, it is, the operator who is manually doing this oil draining. So having a proper, protective equipment, being aware, of the steps that he has to follow, being aware that, even we are talking about draining oil, it can contain a small portion, of ammonia, and that at some point you can get to, to drain ammonia. Having a, a quick closing or so-called spring return valve, that will, guarantee double safety here. Those are very, very detailed things that we can find in different standards, and that will definitely help a lot in preventing, incidents or accidents at this point. Unfortunately, when we look, at some of the numbers from organization like OSHA in the United States, we will find that when it comes to number of incidents or accidents related to, ammonia refrigeration plants, most of the incidents are related to the process of draining oil, even though the accidents might not be always, very big or have a harmful effect on people. This is the most common cause of incidents. So definitely one point to put a lot of attention when designing, but as well when training our operators.
Thanks.
Or possibly consider an automatic oil return.
Then even better, yeah.
Yeah, I have pluses and minuses with automatic oil return. I mean, if the oil has been to the low pressure side, then it is potentially destroyed from contaminations. So pluses and minuses. You don't have to drain oil, but you get less than perfect oil returned. Yeah.
Okay. Another aspect we cannot avoid is leaks. The risk of leaks are ever present, but how can the risk of leaks be reduced?
Well, you can say there has been a lot of focus on leaks over a number of years, and the industry, we can say, has changed behavior. In the past, we saw a lot of valves which were flanged valve, or you can say almost all of them were flanged valve, so with potential leaks with these connections. First, the flange was disappearing from the stop valves. Then later on, the control valves was also introduced as direct welded, also without any flanges. So that is definitely one of the area where the leak potential has been reduced quite a lot. So looking into the various designs, then all these connections, in particular the ones where you have some forces related, as in your pipe system, is a risk. Where you have some moving part, for instance, with some old type of motorized valve with an external packing gland, there is definitely a high risk of leaks compared to, we can say, a hermetical sealed gland with a magnetic coupling where it's totally sealed. So the area from where the leak can happen has over the years reduced quite a lot by these direct coupled valves. And also, if we're thinking about, we can say, the pressure that we are dealing with today compared to what we did about 20 years ago, then it's approximately the double for ammonia. If we're thinking about an ammonia heat pump, where we easily can go up to both 52 or 65 bar. In the past, this was absolutely not the pressure that we were working with, but still, we are able to keep the system tight.
Okay, well, you mentioned less flanges and more welding is a good thing, and I get to think about our own ICF valve here. With the ICF,
it's true.
I think if you think about the ICF valve, you should take we can say a look at what the ICF valve is. A multifunction valve where you have a lot of functions. You have up to 6 functions in the same valve body. Of course, you have flanges where you can take this apart. But if you compare that to what was used years back, then you have thrown away a lot of flange connections where you have, we can say, the pipe forces working on. In an ICF, you have one valve body welded directly into the system. However, you of course have you have to be able to service, but these sealings, they are static sealings, which is not a big issue to keep tight.
The point is that all the function models that we put into the ICF are not subject to these forces from the pipe system. The pipes that are working from pressure and temperature and so on, we don't have those forces on those joints where we put in the function models. And as Niels briefly mentioned, also the magnetic coupling for our ICM valves is also a major step forward in the tightness of this. So it is something completely different when we're with the function models in the ICF.
Yeah, and then you have with the ICF fewer wells also, and which is although a less of a risk is also a risk. So you combine so many functions in one with only 2 wells here. So that in itself should also be
and you can say it is also a valve which is totally assembled from the factory and tested at the factory under these good condition, and when you bring it to the site and you have to weld it in, you don't need to disassemble it. So there is a lot of benefits from a safety point of view, but definitely also from a cost point of view.
Definitely, yes. Well, now we've just talked about leaks, and I think the next obvious question here is talking about how to detect potential leaks, or if there were a leak, and gas detection is of course what I'm thinking about, and but gas detection is it's a requirement by law, but I would say in all countries, but these laws can differ significantly. Isn't that correctly?
Yeah, well, definitely there is, differences into the standard requirements, in different parts of the globe. But I think that we should highlight that there are, very relevant similarities. The very first one and the most important is that this is a requirement for, protecting our a refrigeration system, the people around, you will have the requirement to have a gas detection system almost in every country. There will be, yes, differences, when it comes to the specific thresholds, but you will always be, when talking ammonia, have thresholds related to the toxic part and thresholds related, to the risk of flammability. So the important part here would be, from my perspective, to take a look at the specific requirements of the country where the system is being installed, because it is very common that in addition to the requirements from the standards related to the industry, there you will have on top of that some requirements, that are specific to the country, and that is because, ammonia, it's considered as a hazardous substance, so it will be classified as well within other substances that have to fulfill, certain requirements. And in addition to taking a look at those details, there are, very specific requirements when it comes to the actions, that have to happen in case there is, a potential dangerous situation detected, about control, wiring, power supply. All those small details can be somehow different depending on the standard in the country that we are talking about. But in general, I would say many similarities, and the common thing that we are required to have a gas detection system for our installation.
But also thing here is that you should mention that we also have some tools that can support the customer when they have to select the gas detectors. We have a special application manual for the gas detectors. We also have some possibilities in Code Selector to select the various types of gas detectors.
Talking about selection.
Sorry, no, and I was just going to point out that is very relevant, when it comes to those details, to take a look at the, at the application guide, because it will guide you not just on the part, related to the regulations and selection, but also as well some very good recommendations in regards to the design and other details that have to be taken into consideration when having a gas detection system design and selected. So definitely a very good resource to take a look at.
Yes, definitely, yes. But when you have to select your gas detection system, what is the most important aspects when designing and selecting gas detection system?
Well, I guess that answer will be probably up to debate on what is the most important thing. But I can think of a couple things that are definitely on that on that top list. When it comes to selection, I would say that the most critical thing is to choose the right technology. I mean, in today's market or industry, we have different types of technologies that can help detect ammonia or other refrigerants, and they have different specifications, different properties, and I would say they are to be used for different applications. So knowing the pros and cons of these different type of technologies is definitely very helpful when selecting and designing your system. It can help you, to have a very reliable system, to avoid false alarms that will be, detrimental in the long term to the trust that you have in the system. In general, you have, different levels of detection, the toxic part of ammonia. There is, a specific technology that is, recommended for that end. And then you have as well, the part of the risk of flammability on a band of concentration. And there is another specific technology that is, let's say, recommended for that end. The environment where these, sensors or these technologies are going to work plays as well a very relevant role. So the selection, I'll say, of the right technology is definitely one of the key things here. And here again, we can take a look at, at the application guide. There is very detailed information on this, what I just mentioned, technologies, the way they work, their limitations and their advantages. So a very good resource, again, to take a look and help you with the selection, which I think is one of the key things here.
Yeah, sorry. Yeah, come.
I would also say that the ease of maintenance to ensure that you have a properly functioning system in the years ahead. So easy maintenance must also rate very high on the selection. It should, at least.
Yeah, because that was my next question. Apart from these major questions, there must also be other aspects when choosing your system, and which is important.
Yeah, definitely. I mean, when it comes, to the part of, I would say, the designing your system in regards to components and distribution, you have to take into consideration, the particular things or the particularities of your of the place when it comes, to the space, to ventilation. In this case, we're talking ammonia, so the particular way that ammonia will behave, in the case of a leak, and one, very critical part as well, and that sometimes we forget, to put enough attention to, that is that yes, we have a gas detection system that is, intended to let us know when there is a leak, when there is a concentration of gas that shouldn't be there, that is not expected. But part of that, gas detection system that we have is as well there to address what needs to happen when that concentration is there. Meaning, yes, our sensors will tell us there is a concentration, there is X amount of, ppms, percentage volume, however we want to measure it, in this given room or in this given location. Part of, of our system should tell us as well what needs to be done when that happens. Yeah. And then, we can take a look at the standards. There are some requirements. We can divide it, we can divide them into the automatic responses and the manual responses. Yeah, the automatic ones, I can think of a couple. I guess Niels and Thomas will be, better to give some examples of some automated actions that, that can or should happen whenever there is, a leak detected. But when it comes to the, to the manual part, I guess here is again, very good training on the people that is, operating and working on the system, awareness, of the risk that can be involved by a leak, and a detailed, action list of what needs to be done at different, concentration levels. But I guess a very good or critical part here is as well the automated actions that can happen whenever there is a leak detected. And as I mentioned, I can think of, a couple that will reduce, the potential of the leak, or will, section the system to, minimize the leak that we'll have. But there should be, a long list of actions that can be taken to minimize the risk here.
Yeah, thank you. Moving a little bit away from the gas detection now. We have sometimes there can be situation where we have excess pressure in the systems, and we have some safety devices for that situation. Can you elaborate a bit on that?
Well, yes, you can say when we have a system, we try to control that so the pressure are within the limit which is designed for. We have control equipment that also should take care of what happening during normal operation. But if something happen, we will need to secure our system. First of all, we can say we have pressure switches that should stop the compressor in increasing the pressure and shut down the installation. If that is not sufficient to keep the pressure down, then finally we also should install safety valves in our system. So you can say the safety valve, they are the last barrier for, we can say, a catastrophic failure in our system. So they are very important. But the safety valve is also, we can say, a product where there is a lot of focus on from the authorities that's put up a lot of requirements how these should perform. But one thing which is also very important here, that is to make the right selection of safety valves. They need to be, we can say, fit for the purpose, as a meaning that they need to have the right setting, they need to have the right capacity. But last but not least is that we also need to consider what about the pressure drops in the system, which is connecting up to the safety valve and from the safety valve out into the atmosphere. Here is something that we need to make sure that is done correctly, and it has to be documented that it is correct sized. For that purpose, we can also use Cool Selector to make the selection, as to make the selection of the right size safety valve. But we can also use Cool Selector to calculate the pressure drop in the up and downstream lines, so we are sure that the valve is performing correct and fulfill the requirements in the standards.
Okay, very good. Yeah, we are getting close to the time limit and the time we have allocated for this panel discussion. We have a few minutes left. Any last words? Anything you want to say before we wrap up?
Well, from my end, and now that we were talking, safety valves, and we have just recently talked, gas detection, and we're talking, safety devices. The selection on this part, of the safety valve is definitely a very critical thing, and that will guarantee that the valve is suited for the purpose. But once we have installed it and one is here in operation, we will need as well to take a look at what it requires in terms of maintenance, and that is not just related to the product itself, but as well to the regulations and the standards where the valve that are applying to the place where the valve is installed. Because here as well, on safety valve as well as on gas detection, we will have specific requirements on the country, on the region, from different standards in regards to replacement and calibration or checks to make sure that everything is working properly. When it comes to safety valves, as Niels mentioned, this is your last line of defense, when there is an overpressure. So we definitely need to make sure that this is operating properly. So on this one as well, on the previous safety device, I will say maintenance according to our recommendation and according as well to the to the requirements, legal requirements and standard recommendations is a very important part that we have to follow to keep our devices working properly.
Thank you very much. Yeah, we could have talked for much longer about this subject, and but unfortunately we have to wrap up now. But I would say thank you, gentlemen, for sharing all your insights on this subject. And if you you out there have any questions for us, there will be a Q&A session right after this talk here. There should be a link in your chat right now. I hope to see you there if you have any questions. Otherwise, I would say thank you again for listening, and have a great day, everybody.